The glowing cursor blinks on the screen, delivering a perfectly crafted essay, a stunning piece of digital art, or a flawless block of code in mere seconds. The illusion of pure autonomous machine intelligence is intoxicating. We are conditioned to view artificial intelligence as a sterile mathematical miracle born entirely of silicon, algorithms, and vast server farms humming in air-conditioned data centers. Yet behind this polished veneer of algorithmic perfection lies a profoundly different reality. The engine powering the modern artificial intelligence revolution is not just synthetic computation, it is fueled by an unseen global network of human minds performing repetitive, often grueling tasks to teach machines how to understand our world. To understand why human intervention remains the bedrock of advanced neural networks, we must look at the mechanics of supervised learning. This foundational method of training artificial intelligence requires vast amounts of structured data to function. A raw algorithm cannot naturally distinguish a stop sign from a storefront, nor can it differentiate a hateful slur from a harmless colloquialism. It must be explicitly shown what these things are, millions of times over, before it can begin to recognize patterns independently. The machine is essentially a blank slate, requiring a meticulous teacher to point out every detail of reality, pixel by pixel, and word by word. This teaching process relies entirely on human data labelers. These individuals spend hours drawing digital bounding boxes around pedestrians in street imagery, transcribing muffled audio snippets, and categorizing the emotional sentiment of thousands of text fragments. Every time an autonomous vehicle successfully brakes for a cyclist, it is because thousands of anonymous workers previously annotated countless images of bicycles, teaching the machine's vision system what to look for. The algorithm merely mimics the collective ground truth established by this immense distributed human effort. Without this painstakingly categorized data, the most sophisticated models would remain entirely paralyzed, unable to parse the chaos of the physical and digital world. The demand for this meticulously curated data has birthed a massive, specialized industry operating just out of public view. Companies like Scale AI and Appen have positioned themselves as the critical supply chain managers for the artificial intelligence boom. They act as intermediaries, securing lucrative contracts from the world's largest technology conglomerates and automakers, promising to deliver the high-quality annotated datasets required to train next-generation models. These firms have transformed the tedious task of data annotation into a highly optimized global logistical operation, moving billions of data points through a complex pipeline of human verification. The financial scale of this hidden infrastructure is staggering. Scale AI, founded by a 19-year-old dropout, rapidly achieved a valuation exceeding $13.8 billion by cornering the market on data labeling for autonomous driving and generative text models. Appen, a publicly traded Australian company, similarly rode the wave of machine learning demand, generating hundreds of millions in revenue by crowdsourcing human intelligence. These valuations reflect a fundamental truth of the modern technology sector. The companies that control the flow of human-verified data wield immense power, acting as the unavoidable toll booths on the road to artificial general intelligence. Yet the immense wealth generated at the top of this supply chain stands in stark contrast to the economic reality at its base. The actual labor is performed within a sprawling, unregulated gig economy. Platforms like Amazon Mechanical Turk pioneered this model of distributed microtasks, where workers log on from personal computers to complete brief assignments for pennies per task. There are no salaries, no healthcare benefits, and no job security. The workforce is entirely transient, paid strictly by the piece, and subject to algorithmic management that dictates task availability and compensation rates with opaque, unforgiving logic. Anthropologists and labor researchers have coined a specific term for this phenomenon, calling it ghost work. It describes labor that is deliberately obscured from the end user to maintain the illusion of seamless automation. When you interact with a smart speaker or a sophisticated chatbot, the design intentionally hides the human hands that categorized its training data or corrected its early mistakes. This deliberate invisibility marginalizes the workers, stripping them of the recognition and bargaining power traditionally associated with essential labor. They are the factory workers of the 21st century, yet they are completely isolated from one another, connected only through a digital interface. The geographic distribution of this ghost work reveals a distinct pattern of global economic arbitrage. Technology giants headquartered in the wealthiest cities on Earth routinely outsource data annotation to regions with significantly lower labor costs. Massive populations of data labelers are concentrated in countries like Kenya, the Philippines, India, and Venezuela. In these regions, a daily wage of a few US dollars can be economically viable, though often still precarious. The artificial intelligence industry effectively leverages global economic disparity to train its models cost-effectively, creating a digital assembly line that stretches across continents and time zones. Beyond the economic precariousness, the nature of the work itself often carries a severe psychological burden. This is most acutely felt in the realm of content moderation and safety training for generative artificial intelligence. To ensure that a highly capable language model refuses to generate instructions for illegal acts or toxic hate speech, it must first be trained on what that material looks like. Human workers are tasked with reading, viewing, and classifying the darkest, most disturbing content on the internet. They act as the psychological filter for the machine, absorbing the trauma so the end user never has to. Reports have repeatedly surfaced detailing the mental health crises among workers contracted to filter this toxic data. Individuals in outsourced facilities have described spending 8-hour shifts reviewing graphic violence, child exploitation, and extreme abuse, often with minimal psychological support or counseling provided by the contracting platforms. The toll of this continuous exposure is profound, leading to high rates of burnout, anxiety, and post-traumatic stress. The safety and sterile politeness of consumer-facing artificial intelligence products are directly subsidized by the psychological distress of these invisible workers. The conditions under which these workers operate also have direct, undeniable consequences for the technology itself. The accuracy of a supervised learning model is entirely dependent on the quality of its training data. When labelers are paid fractions of a cent per task and pressured to maintain punishing speeds to earn a living wage, errors inevitably multiply. A rushed worker might mislabel a medical scan, incorrectly categorize a pedestrian, or fail to identify a subtle nuance in language. These human errors are then baked into the foundational architecture of the resulting artificial intelligence, creating brittle models that fail unpredictably in the real world. Furthermore, this reliance on human judgment introduces the critical issue of AI model bias. Every human being carries inherent cultural, linguistic, and social biases, whether conscious or unconscious. When a worker in one part of the world is tasked with labeling data that will be deployed globally, their specific cultural context shapes the machine's understanding of reality. If a dataset used to train a hiring algorithm is annotated by individuals with implicit biases against certain demographics, the algorithm will learn to replicate and scale that exact discrimination. The machine does not transcend human prejudice, it mathematically codifies it. Recognizing these bottlenecks of cost, quality, and ethical liability, the artificial intelligence industry is aggressively attempting to automate the very process of data labeling. Researchers are pioneering techniques like self-supervised learning and synthetic data generation. In these paradigms, advanced models are used to generate training data for other models, or algorithms are designed to find patterns in unlabeled data without human intervention. The goal is to break the dependency on the human in the loop, creating a closed ecosystem where machines teach themselves at a scale and speed impossible for biological workers to match. Despite billions of dollars invested in these automated training methods, the complete elimination of human oversight remains a distant, perhaps impossible horizon. Synthetic data often suffers from a phenomenon known as model collapse, where an artificial intelligence trained purely on machine-generated data begins to degrade, amplifying errors and losing its grip on the nuances of the real world. To prevent this degradation, periodic injections of high-quality, human-verified ground truth are continually required. The human workforce is not being replaced. Its role is merely shifting toward higher-level verification and complex edge case resolution. As the critical nature of this labor becomes impossible to ignore, a nascent regulatory movement is beginning to take shape. Labor advocates and policymakers in Europe and North America are scrutinizing the gig economy platforms that facilitate data annotation. Discussions are emerging around establishing minimum wage standards for digital piecework, mandating psychological support for content moderators, and requiring technology companies to disclose the geographic and economic origins of their training datasets. The opacity that has defined the artificial intelligence supply chain is facing unprecedented legal and societal pressure. This growing scrutiny forces a fundamental reevaluation of how we value the creation of machine intelligence. For decades, the narrative of technological progress has celebrated the brilliant engineers, the visionary chief executives, and the sheer computational power of the hardware. The thousands of individuals categorizing data in internet cafes and crowded apartments were treated as an embarrassing anachronism, a temporary bridge to true automation. Acknowledging their indispensable role shatters the myth of the self-made machine, demanding a more honest accounting of the human capital required to build the future. Looking forward, the dynamic between the technology giants and the global data workforce will only grow more complex. As models move beyond simple image recognition and text generation into complex reasoning and specialized domains like law and medicine, the demand for expert-level annotation will skyrocket. The gig economy model of paying pennies for basic tasks will prove insufficient for training models that require deep domain expertise. We are likely to witness the emergence of a tiered labeling industry where highly educated professionals are contracted at premium rates to teach machines the intricacies of their respective fields. This evolution mirrors the historical trajectory of previous industrial revolutions. Just as the textile mills of the 19th century relied on unseen, exploited labor before labor movements forced systemic reform, the artificial intelligence boom is currently operating in a frontier of unregulated human effort. The transition from a shadowy ghost work economy to a recognized, regulated digital trade will be a defining economic struggle of the coming decade. The outcome will determine not just the cost of artificial intelligence, but its fundamental ethical foundation. The implications extend far beyond the balance sheets of Silicon Valley. For many emerging economies, the data labeling industry represents a complex, double-edged sword. It provides vital income streams and digital literacy to populations often excluded from the global technology sector, yet it simultaneously traps them in a cycle of low-value, repetitive labor, serving as the digital underclass for products they may never afford to use. The global distribution of artificial intelligence wealth remains deeply asymmetrical, heavily weighted toward the corporations that harvest the data rather than the workers who refine it. Ultimately, the story of advanced artificial intelligence is not just a tale of algorithmic breakthroughs and endless computational scaling. It is a profoundly human story, written in millions of tiny, discrete actions performed by a massive, invisible workforce. Every coherent sentence generated by a chatbot, every successful navigation by an autonomous car, and every accurate medical diagnosis assisted by machine vision carries the hidden fingerprints of human labor. Recognizing this unseen workforce is essential for understanding the true cost, the inherent limitations, and the profound ethical responsibilities of the artificial intelligence era.